Domain. Domain of a function is all possible x values. These are the values that are allowed to be plugged into an expression. In some cases, there are limitations and there are certain values that would cause problems or clog our function machine. Specifically, think of a denominator and the fact that you cannot divide by 0. Rational functions are the ones that look like fractions and they have a denominator, so you have to avoid any values that you would plug into that function that could make the denominator 0. Then you can consider square root functions. Square roots have an even index, meaning being an index of 2, so we consider radical functions with even index because we are not allowed to take a square root of a negative number, or more specifically, the square root of a negative number is simply not a real number. So we're going to take a closer look at those two types of functions. Starting with f of x equals x squared plus x minus 12. This is actually a polynomial function. More specifically, it's a quadratic function. All polynomial functions have a domain of all real numbers. There's no work to be done. There's nothing else to consider. You simply state the domain as all real numbers. There are no restrictions on what x is allowed to be. So in interval notation, we would write from negative infinity to infinity. Next we have g of x equals 2 divided by x plus 5. This is a rational function. It looks like a fraction, so it has a denominator. We need to take that denominator and set it equal to 0 so we can decide what x is not allowed to be. So we take the denominator x plus 5, set it equal to 0, solve this equation by subtracting 5 on both sides, and we get x equals 5. This means that our x is not allowed to equal negative 5. So our domain is all real numbers except negative 5. In interval notation, you use from negative infinity to negative 5, union negative 5 to infinity. G of x equals 1 divided by x squared plus 4. This is also a rational function. However, in this case, when you take x squared plus 4 and set it equal to 0, you find that there are no values that can be plugged into x to make the denominator equal 0. So this domain is all real numbers. F of x equals the square root of x plus 2. This is a radical function with even index. A square root has an index of 2, so this is a radical function with even index. So our method is to take the radicand, which is the x plus 2, and set it greater than or equal to 0. Solve this inequality by subtracting 2 on both sides, and we get that x must be greater than or equal to negative 2. In interval notation, we use a bracket from negative 2 to infinity. Now find the domain of g of x equals 7x squared divided by x minus 2 times x plus 1. We have a rational function, looks like a fraction, means the denominator can't equal 0, so we're going to set the denominator equal to 0. Hopefully this makes you think of the zero product rule, which says when you multiply two algebraic expressions and the result is 0, one of those algebraic expressions must equal 0. So the zero product rule allows us to pull this apart so that we have x minus 2 equals 0 and x plus 1 equals 0. We can then solve these individual equations to get x equals 2 and x equals negative 1. Therefore, we know that x cannot equal 2 or negative 1. The interval notation of this is a bit messy, so we'll go ahead and use set builder notation for this. And the set builder notation says x such that x does not equal -1 or 2. And finally, in summary, to find the domain of a polynomial, rational, and radical function, the domain of a polynomial function is simply all real numbers. To find the domain of a rational function, you set the denominator equal to 0 to find what the values of the variable cannot be. And finally, for a radical function with even index, you set the radicand greater than or equal to 0.